There is a parable of the blind men and an elephant. It is a story of a group of blind men who have never seen an elephant before, and just by touching the elephant, they learn about it and imagine of what the elephant is like. Each blind man feels a different part of the elephant's body and then describe the elephant based on their limited experience and their description of the elephant. All these blind men have a meeting, and each of them argues that he is right and what the others have perceived is totally wrong. The moral of the story is that we human beings have a tendency to claim absolute truth based on our limited work experience and reject other people's limited point of view, which may also be equally true. Most disagreements are caused by different perceptions that created different realities. Sometimes we are always excited about our new ideas and tend to focus only on those experiments that we think would give us results and discard all those experiments which didn't give any results. Let me give you an example. For quite some time, researchers thought that P53 was an oncogene and did all those experiments which confirmed that it was indeed an oncogene. However, some years down the line, other scientists were getting a totally opposite result, a tumor suppressor. And today, we know that P53 is a tumor suppressor, which is the guardian of the genome. So, what can we learn from this? Rather than coming to an immediate conclusion about an event, idea, or person, or even the details of the cells that we are working on, try to pay more attention and probe deeper into the subject in order to understand it more completely. Just like our cells have molecules that help in progression of cell cycle, we also have molecules that are checkpoints or tumor suppressors in cell cycle that detect any kind of abnormality. Now let me introduce you to a concept called negative capability that keeps you on guard from having false dichotomies, fixed mindsets, and complete confidence in your own thoughts. It's about resisting quick explanations, sitting with your doubts, and questioning your assumptions. It's a passive process that can help you become more creative. It's an incubation time for you researchers to focus on what exactly is happening inside the system you are exploring. Here's when you become like a poet and get into a deep, pensive mood like William's Wordsworth to help you figure out the essence of the work you are doing. You can start by asking yourself, why do things work the way they work? Why do you think the way you think? Are there any alternative ways to navigate your thoughts? Negative capability helps us enjoy the process of discovery rather than rushing to a seemingly perfect solution to our questions. Let's take an example here. Maybe you want to bring gene editing to the clinic. Here's where you can ask why gene editing opts for NHEJ pathway. Or are there any alternative ways to navigate this NHEJ pathway and still use gene editing in an effective way? Why do you think that gene editing technology will make it to the clinic? When you answer these questions, you get more mental clarity and will be able to come up with a better research proposal. Negative capability goes hand in hand with continuous learning and it discourages arrogance, but at the same time, it encourages personal growth. So let's check the 5 ways you can practice this and become more creative. So the first tip is learn from Master Oogway. In the movie Kung Fu Panda, Master Oogway was such an adept warrior that he too embraced uncertainties without any judgment. In the movie, he says, I don't know, so very effortlessly. He also mentions that there is always something more to learn, even for a master. Lastly, in the movie, Master Oogway mentions that there are no accidents. This tells us to learn to get comfortable with the unknown realm. As we keep exploring, we have something more to learn. Even Nobel laureate Jennifer Doudna puts it, the more we know, the more we realize there is to know. So embrace intellectual uncertainties. The next tip is stay open minded. Things aren't always what they seem to be. So collect more information, read a lot of books, and get different perspectives. Expand the possibilities by asking, what if? An example of this is the Her movie, which gives a glimpse of how voice assistants will be like in the future and how we can even fall in love with them. Or you could also read science fiction. People say that no writer is more renowned for his ability to foresee the future than H.G. Wells. His writing predicted the aeroplane, space travel, the atomic bomb, satellite television, and even the World Wide Web. That's awesome to have such a terrific imagination. Now, even during the COVID period, the pandemic times, there was a lot of news that some books and movies predicted the outbreak of this deadly coronavirus years ago. So, read books to expand the limitless possibilities that exist out there and get different perspectives of people. The next tip is sit with your doubts and clarify all of them. So, firstly, make a list of all the doubts you have regarding your research work. Then, try to look at the impact of the work you're doing. So, you could probably ask, are you using the right techniques to answer your question? Maybe you haven't done sufficient sample analysis to come to any conclusion about your data. Or maybe, what are the consequences of such a technology? Do you envision the future of technology that you've developed? Ever since Jennifer Doudna and Emmanuel Charpentier published their first work in 2012, there has been an explosion of publications in the field of gene editing showing extensive possibilities with this tool. But there can be dangerous consequences as well. So, with power comes great responsibility. I'm sure you know the case of He Jiankey, who unethically used CRISPR-Cas gene editing system to edit DNA in human embryos to make them less susceptible to HIV. So you have to give thought as to how your work is going to impact not just the scientific community alone, but in this whole world. So if you've seen the movie Jurassic Park, then you know that it showed a possibility that scientists could resurrect dinosaurs just from their DNA sequences. Now, in gene editing, scientists are attempting something similar, and they are attempting to resurrect the woolly mammoth to better understand the climate change and the impact of global warming. So, take time to think about the consequences and the impact that your work could make. The next tip is revisit your ideas. Change your mind as you get new information. Be flexible and adapt your research to new information that you get every day in your area of research. Here, once again, I'd like to quote Jennifer Doudna. Pay attention to what's happening in biology because it's changing very quickly. Now, let me give you an example. There was a time when directed evolution was used to engineer the Krelok-Sp system to target the HIV genome. Soon, Seraphians stole the show and showed that you could edit the CCR5 gene with the zinc fingers. Anyone working in that window period from 2007 to 2010 wouldn't have thought that talents and CRISPRs were just on their way to change the way gene editing would be done in future. But when you keep revisiting your ideas, you know how to take shortcuts and do it much better than when you started off. This can skyrocket your progress in research. Another reason to revisit your ideas would be to bring about a paradigm shift. The term paradigm shift was introduced by Thomas Kuhn, Everything changes when you open from another mental attitude. Let's take this example. Let's assume that all the while you were seeing the number 6 and you forgot about it. After a few days, when you revisited the problem, it suddenly appeared to be 9. Sometimes stubborn problems require a shift in paradigm. In order to understand this better, let's solve a puzzle together. Here's a car problem. What is the number of the parking space containing the car? Do you think it's arithmetic progression or a geometric progression? Feel free to work it out. Or maybe you should revisit the problem sometime later and perhaps you'll get a paradigm shift. I'm not going to keep you waiting for that. I'll give you the answer right away so that you understand what I'm talking about and learn to implement it in your own research. So let's get into the problem. Now just turn the image upside down. Now what does this look like? 86, 88, 89, 90 and 91. So what's the parking lot number? It's number 87. So now you've got it, right? Sometimes that is what you need to solve a problem. A simple logic. A short break from your work, which is actually the incubation time that's preparing you for a paradigm shift. Suppose you are in a familiar situation, let's say the routine lab work you're doing, and you suddenly feel as if you're experiencing something new. This is called Puja Day, and this is the key to becoming a better questioner and a more creative and innovative thinker. In this example, you are seeing the same numbers again and again, but you're not getting the answer. But when you take a break, you may get an idea to turn it upside down, and then you've cracked the answer. Now, let's move on to our last tip. Question your assumptions. Did you know that science doesn't progress because people change their views? Rather, each new generation of scientists has different views. As old generations pass away, new ideas are accepted and the scientific consensus changes. That's why they say that the future lies in the youth. So, young researchers, please ask questions. Don't make assumptions unless you know the whole story. Maybe with your blood results, you make a model of how things are operating inside the cell. But you didn't know that another pathway was also intersecting with this pathway, and that's why you saw these results. So, you need to question your assumptions. Let me give you one final example. Have you seen the movie Moneyball, in which a guy named Billy Bean questions the conventional wisdom of playing the baseball game? He then shows how, by using a proper strategy and statistics, no matter how the players were, they could win many games in a row. Just by using statistics, they could make better decisions on the abilities of players and win many games. So, for the young researchers, the advice is keep on questioning your assumptions and record your observations till you get a clear picture that could help you take your next steps. And now I would like to know, so which is your favorite tip in this video? Comment below and let me know why you think so.